Good afternoon, my dear students. Welcome to one more amazing session from Infinity Learn by Sri Chaitanya. This is Suresh, Faculty of Chemistry from Infinity Learn Studio on YouTube platform. How are you, my dear students? Can you all able to hear me? Can see me? Please give a confirmation. Good afternoon to you all. Right? Good to see. Hello, Annamani and the other students still waiting? Okay, just make adjust yourself. Today we are going to present the total deep dive into the solution for NEET examination. Rohan, hi. Rohan. So welcome to YouTube channel NEET Step Up 2025 program. In this YouTube platform, Infinity Learn is offering you all sessions related to NEET examination right from 12 o'clock to evening 6 o'clock. Both physics, chemistry and biology sessions are absolutely free for you guys, and these sessions are absolutely useful for those students who dropped for 12th standard and those who are studying 12th standard also very important, and you can use these sessions and you can get use of this and can improve your score and can improve your rank, and you can be a topper as well. Rohan, this year 642, congratulations. Next year 720 आना बेटा. रोहन आ सकते हैं? बिल्कुल आ सकते हैं. कोशिश करो, अच्छा तरफ अभ्यास करो, आपको 720 मिलने की इतना खास बात नहीं है, आसान काम है, but you have to follow the lessons every day without fail and you follow according to our guidelines. है ना? Right to see it's raining a lot out there and monsoon is already going on, so it is raining probably in your areas also. Take care of your health, and you're a biology student, you know all infectious more proliferating during this season, right? Take care of your health, है ना? Not getting college, oh why again drop? Yes, drop करने तो और अच्छा होगा, आपको और अच्छा होगा, है ना? ऑल स्पोर्ट्स सर केमिस्ट्री का क्वेश्चन नहीं बन रखते, कोई प्रॉब्लम नहीं बेटा. आज का एक कॉन्सेप्ट सेशन है, कल ये सेशन ये टॉपिक से हम मल्टीपल चॉइस क्वेश्चन नीट के वजह से निकाल सकते हैं, सो दैट यू विल बी डूइंग वेरी गुड इन द एग्जामिनेशन. सो टुडे इज कॉन्सेप्ट, टुमारो इज मल्टीपल चॉइस क्वेश्चंस, एक्सपेक्टेड मल्टीपल चॉइस क्वेश्चंस फॉर टुमारोज एग्जाम, राइट? है ना? यस. रोहन, इज इट फाइन? Great to see. And so don't worry about the Supreme Court, what happened with the arguments and all, just leave it. आपको जो भी करना है वो करो, अच्छा करो, अच्छा रिजल्ट आपके पास मिलेगा, है ना? राइट. Thank you very much. All sports shorts. I want to know your good name, please, so that instead of calling you all sports, I just want to call you with your sweet name, right? Annamani, nice to see. Yes, we have a very good gathering over here, and without any delay, we'll start with solutions and colligative properties. And in the solutions and colligative properties, let us see, in this YouTube channel, we are going to provide mostly in 90 minutes, most of the concepts will be covered. If any concept that is left for today, tomorrow we are going to just continue and start with multiple choice questions. Is that fine? एक thumbs up and एक fiery emoji डालो. अरे हर चीज के लिए एक कुछ प्लान बनाना जरूरी है ना? सो ये सॉल्यूशंस एंड कॉलिगेटिव प्रॉपर्टीज नीट एग्जामिनेशन से आपका कम से कम 2 क्वेश्चंस निकलेगा, है ना? सो एक डायरेक्ट क्वेश्चन आ सकते हैं और दूसरा भी इनडायरेक्ट भी आ सकते हैं. मोस्टली न्यूमेरिकल एज वेल एज थ्योरी बेस्ड क्वेश्चंस आर मोर प्रोन फॉर दिस पर्टिकुलर चैप्टर. ओके आशीष, हाय. आपको स्लाइड कैसे दिख रहे हैं? एलिगेंट है? आशीष, yes, if you like this slide, introductory slide, एक बार fire emoji देना, so that we can start without any delay. So there is a good gathering of the students. Logvanayagam, good afternoon. So use this short box generously for academic discussion, so that we can have a kind of live interaction, so that your knowledge is going to be rise like anything. All okay. Logvanayagam will start. Ashish will start. Okay, so deeper dive into the solutions, right? In this, what is the actual plan, the topics that are required, concentration terms, these concentration terms which is already linked with stoichiometry, basic concepts of chemistry in the grade 11. and in that you will start with molarity, molality, normality, all things. We just have a kind of a short recap of that, and after that solubility, a solute and a solvent gives rise to solution. In that, how much solute is dissolved, that is called as solubility, and connected to that, gas is soluble in a liquid, that is explained by Henry's law, and you will get Henry's law, and this is connected with some gas state formulas also we will see, and we'll talk about the vapor pressure, and eventually we go into the Raoult law and positive deviation, negative deviation, and ideal solution, and इसके graphs भी करना है, and colligative properties. The colligative properties, how many colligative properties are there? Ashish, you tell me. Logvenheim, how many colligative properties are there in Uday Niwal? Hi Uday Niwal, good afternoon, be regular in the sessions. I know you, you are a good student, you give answers like a fire. Just I want to see the same answers to be given in 2025 NEET examination. तैयार है बेटा? हाँ. Good afternoon Uday Niwal. So colligative properties, how many colligative properties are there? Logvenheim, come on. How many are there? There are 4 colligative properties: relative lowering of vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. So we'll discuss that also, and at the end want half factor. अगर आपका क्वेश्चन आना का ज्यादा संभावना कहाँ से? यहाँ से. Definitely in the NEET 2025 examination connected with these two, you will be having definitely one question. And the rest of the things you can have a question anywhere, mostly in the vapor pressure and Raoult law, and related to concentration terms. We can take this kitty into the basic concepts of chemistry, in stoichiometry, mole concept, their concentration terms. Again, we studied, and we will be studying here itself. So, any doubt? So this is actual plan for this particular topic in NEET 2025 expectation, my dear students. Without any delay, we get into the actual concepts. So all volume dependent concentration terms are dependent on the temperature. This is very important. Based on this simple statement, one question has been already asked in NEET examination, and also so many competitive examinations that happen in India for last decade. So more than 4 or 5 times it is asked. I just want to elaborate this one. So the concentration terms are there. So certain concentration terms which are dependent on the temperature, which are independent on the temperature. So the strength, molarity, normality, weight, volume percentages, those depend on the temperature. And when you see the temperature independent wala, so the molality, mole fraction, parts per million, and weight percentage कितना है? 1, 2, 3, 4 चारों चीज का ये टेम्परेचर में डिपेंड करता ही नहीं. सो इंडिपेंडेंट. नीट में आपका क्वेश्चंस कैसे निकलेगा इससे? सो नीट में आपको सीधा पूछा जाएगा which of the following concentration term is dependent on temperature और independent on temperature. combinations भी कर सकते हैं. So that this is a slide which give you a crystal clear picture to you guys, so that you can give a perfect answer अगर नीट में पूछा जाएगा तो आप दे सकते हैं उदय. हाँ, ओके, क्लियर? और कुछ डाउट है ना? अरे what is a strength, what is a molarity, and what is a normality? आपका definition formula भी खास बात है नहीं? So you all know about this, right? So what is the formula of the molarity? What is the formula of the normality? What is the formula of the molality? Who will know? Logvenheim, you tell me the molality का definition बोलो. Molality का definition. And strength, it is given per gram per liter, number of grams of the solute present in a liter. Molarity is equal to number of moles per volume expressed in liters, and normality is number of gram equivalents, you can say number of equivalents, you can say, upon volume in liter, and weight percent, volume percent. we know it, the molality. Molality is equal to number of moles per weight of the solvent in kg, and mole fraction is equal to N1 by N1 plus N2. So like that, ppm it is for 10 power 6 के लिए, percentage it is for 100. So this is the one where you can see the interrelation between the normality and the molarity. Normality is equal to molarity into n factor, है ना? And the relation between the molarity and mole fraction, if you see the previous classes, all the relations are given, and these are the temperature dependent wala, these are the temperature independent wala. Yes, Ashish, the total moles of solute contained in a So, can you able to hear me clearly? Just give a confirmation. Just give a confirmation. Anamani, can you give a confirmation about, can you able to hear me? Can you able to see me? Kunal Shiti and Uday Nival. Yes. Hello, Kunal Shiti. Can you hear me? Confirm. Can you confirm? Yes, sir. Thank you, Logo Vinagam. So let us go ahead with the slides, which gives a lot of information that you can download these slides in a PDF format in Telegram channel. In the description box, Telegram channel is also available. You can get into that, and we are going to give the total NEET related syllabus and the course content. Okay, it is all about free of cost. So description box mein mile. Okay, so let's talk about types of solution. Based on the amount of the solute dissolved in the solution, the solutions are classified into unsaturated solution, saturated solution, and supersaturated solution, right? So let us talk about the solubility. So solubility is the maximum amount of the solute which can be dissolved in a given amount of the solvent or a solution at a given temperature is called as a solubility. अगर कम सोल्यूट डिजॉल्व करेंगे तो सॉल्युबिलिटी कम है, अगर ज़्यादा होने तो ज़्यादा सॉल्युबिलिटी. ए सैचुरेटेड सॉल्यूशन में डिजॉल्व्ड सॉल्ट एंड अनडिजॉल्व्ड सॉल्ट इक्विलिब्रियम में रहना है, and we are going into the dissolution of the gas in the liquids. So factors affecting solubility is very important. What are the factors that affect the solubility? Factors affecting solubility: first, nature of the solvent and nature of the solute. You know, polar solutes are soluble in polar solvents, and non-polar solutes are dissolved in non-polar solvents. Ionic substances like sodium chloride is soluble in water. Water is a polar, high dielectric constant. Ionic बारे में अच्छी बात करो, so solubility of ionic substance is directly proportional to dielectric constant. If you consider all solvents, water is the solvent which has highest dielectric constant. That's the reason why water is said to be a universal solvent. And अगर temperature of the system, अगर temperature बढ़ते जाएगा, solubility बढ़ते जाएगा. Yes, like solute dissolves like solvent. Yes, exactly. So polar चीज का polar solvent में, non polar चीज का non polar solvent में dissolve करने का ये rule है, solubility rule है. log Vinayagam, that's good. Pressure of the system. Pressure of the system, मान लो if you take the solid and if you take the liquid, if you take the gas, so सिर्फ ये प्रेशर गैसेस सोल्यूट्स को भी इस्तेमाल कर सकते हैं, लेकिन सॉलिड का लिक्विड का नहीं इस्तेमाल कर सकते. Okay, let's talk about the effect of pressure on the solubility of the gas. So if you see this, nature of the solute and the solvent, higher the intermolecular force interaction between the solute and the solvent, higher will be the solubility. And example, ammonia is more soluble in water than carbon dioxide. You can say carbon disulfide also, you can take carbon, CS2 is a liquid. Okay, better you take CS2 instead of water. And you can also say based on the nature of a dissolution, yes, nature of dissolution bhi acha baat hai. So you can say temperature plays a role. When you dissolve in a substance in a solution. So it is going to give the heat out, exothermic process, or sometimes it is going to absorb heat in, that is going to be endothermic solution. Abhinav, you are late for 9 minutes. You are late for 9 minutes beta. So if it is endothermic process, अगर टेम्परेचर बढ़ते जाएगा सॉल्युबिलिटी बढ़ते जाना, क्योंकि एंडोथर्मिक में टेम्परेचर अंदर आ रहे हैं, so that अगर टेम्परेचर increases, heat content of the system increases and the solubility is increases. एंडोथर्मिक प्रोसेस का डेल्टा H is equal to पॉजिटिव ली-चार्ट-टेलर्स प्रिंसिपल का हिसाब से, राइट बेटा? ली-चार्ट-टेलर प्रिंसिपल कहाँ पढ़ा? लॉग-बेनाइगम, केमिकल इक्विलिब्रियम, है ना? So time, you just be on time, my dear Abhinav, right? So Abhinav is my favorite student on the YouTube platform. He is coming regularly and attending the class without fail, but he comes late, 9 minutes 10 minutes late. माफी कर दिया, हर दिन माफी करना है क्या? So try to be on time. ओके अच्छा तरफ सुनो, अच्छा तरफ अभ्यास करो, अच्छा तरफ मार्क्स भी नहीं लेगा, है ना? यस आशीष, फाइन? यस. नाउ एक्सोथर्मिक हीट बाहर निकल रहे हैं, so that is what you call it as delta H is going to be negative. So in that dissolution process, अगर temperature increases, solubility decreases, है ना? So this is the fundamental rule for any kind of process. So exothermic होगा और endothermic भी होगा, है ना? Right. So let's talk about, so when you dissolve sodium chloride solid in the water, you are going to be getting Na plus in the aqueous and Cl minus in the aqueous. This process is called dissolution process. This dissolution process has three major steps: thermodynamics, and we are connected to chemical bonding, and we are connected to solutions. So three topics. एक चीज है, it involves the separation of solvent molecules, okay, and step two, separation of solute molecules. So solute and solvent दोनों मिक्स करके आपका होमोजीनस मिक्सचर सॉल्यूशन बना है. पहले सॉल्वेंट सेपरेटेड सो दैट सोल्यूट अंदर आना है, फिर भी सोल्यूट भी सेपरेट करके सॉल्वेंट में मिक्स करना, सो दैट सोल्यूट एंड सॉल्वेंट मॉलिक्यूल्स मिक्सेस. सो फॉर दैट स्टेप वन प्रोसेस डेल्टा H, and step two process delta H2, and step three process enthalpy change is going to be delta H3. So if you take solubility of carbon dioxide in the water, so this is, you are going to get a carbonated water. So that if you take a carbonated water at the low temperature, you are going to be get more solute in it. Whereas if you take in the hot water, this is hot now, so you can see it is a hot now. So see the animations that are presented for you guys, so you will be getting a better understand, है ना? So cold water and hot water, the carbonated water is going to be more soluble in cold water or hot water, you tell me? You tell me? Yes, in the cold water. Why? Because dissolution, oh yes, dissolution of gas in a liquid is favored at low temperature, not favored at high temperature, क्योंकि ये solubility of the gas in liquid is exothermic process. Overall kinetic energy is decreased. So you can think logically in terms of, thermodynamics also, because thermodynamics we discussed in the previous classes, आधा कर चुका and आधा next week में आना है, so that there you can see the concept of entropy, randomness, and overall energy, and everything we are going to discuss. So let's talk about, when you talk about this one, the evaporation is a liquid going into the gaseous state. As the time increases, you take a water and keep it here for several hours, the water is going to be evaporated, that you can't see it. But the evaporation of water is slow, whereas evaporation of the like hand sanitizer kind of things is going to be fast. So water में intermolecular forces है, so that evaporation is a slow process, whereas if you take about alcohol, उसमें intermolecular forces कम होता है, evaporation ज़्यादा होता है. So evaporation plays a crucial role here. Yes, you can say here, yes, here it is, the intermolecular forces among the molecules, the gas particles and the liquid particles, there are some intermolecular forces. That intermolecular force, van der Waals forces, these van der Waals forces, London dispersion forces and ion dipole forces, dipole forces, and hydrogen bonding, these are all we studied in the gas state 11th grade and introductory page mein milega. So let's talk about effect of pressure. Gas is in equilibrium with liquid in solution. You take a liquid here. Yes, Sangeet, kaise hai? You are from MP, right? You are from MP, Indore, somewhere you said, right? Good afternoon. I remember everybody's performance when you give the answers in the continuously in the session, right? If you keep quiet in the chat box, so I just simply take an attendance and leave it. If you keep interacting with us, I can take the pulse of the student, I can say who is doing the better, right? That's good, my dear students. Here, when the gas, it is a piston, when the pressure is applied by movable frictionless piston, the gas is going to be more soluble in the liquid. Gas is compressible, है ना? That's good, very nice. So this gas is going to be going into the liquid like this. So effect of pressure, solubility of carbon dioxide in water. So this is your soda and this is your water, and if you add a little bit of methyl red, so it is going to change its color. If you take methyl red, it is going to be red. Why? Because इसका pH 4.4 है, near 4 का अंदर होगा, and इसका pH 6 का ज़्यादा होगा. So that if you take this particular liquid, you can see carbon dioxide is dissolved here. Carbon dioxide is soluble in water. You can see these many animations, beautiful animations. So solubility of carbon dioxide is decreased when the pressure is increased, solubility increased. When the pressure is decreased, solubility is decreased. And this kind of understanding gives a good impact and better understanding of this session. I am fine, thank you, Sangeet. Okay, solubility is increased. Yes, yes, no problem, you are late, I know, Hanam. So try to understand these animations, how the things are going on, right? And let us say gas, effect of pressure, gas is in equilibrium with the liquid solution. So I just want to say simple thing, this is a liquid, you can say it is a water, and a carbon dioxide is pressurized. As the pressure increases, solubility of carbon dioxide is increased. This is what you call it as soda or carbonated water. Soda or carbonated water. So that is what is happening in making of the soda. You may be having domestic soda makers at your home. Okay. So this is the way rate of dissolution of a gas is equal to rate of escaping of the gas from the liquid. And also, so pressure increases, equilibrium gets disturbed. So the more gas molecule escape into the solution phase to restore the equilibrium. So that increase in pressures, increase in the solubility. I want to say here solubility of the gas is directly proportional to the pressure of the gas. That is the principle related to making the soda. We all like soda, cool drinks and all. It is nothing but called Henry's law. So if you just increase the pressure, population density of the gas molecules increases so that they are forced to get into the liquid, right? Abhinav, Annamani. Yes, लैग हुआ. ओके ओके, कोई प्रॉब्लम नहीं, लैग चल रहा है. कैन यू एबल टू हियर मी क्लियरली? Can you able to hear me clearly? Yes, let's talk about Henry's law now. Today I made amazing slides for you guys for your betterment, right? So let's talk about Henry's law. That's what we discussed so far. The solubility of a gas in a liquid phase, Henry's law. The solubility of a gas in a liquid phase at a given temperature is directly proportional to its partial pressure of the gas present in above the solution. The solubility the gas molecule is getting into the liquid is depend on कितना pressure आप दबा रहा है ऊपर से, है ना? More the pressure, more will be the solubility. ये चीज है, ये दिमाग में रखो, ये ट्रिक है. More pressure, more will be the solubility, है ना? So that we can see in the mathematical way. When oxygen and nitrogen is there, you can see the pressure is shown here 30, near about 30. It is going to be pressure is 90 and pressure is 120. So it is the application of partial pressures and Dalton's law. Remember Dalton's law. Dalton's law. If you say the pressure is P1, if you say the pressure is P2, and if you say the mixture contain pressure total is equal to pressure P1 plus P2, है ना? एंड ये वाला चीज आपको इस्तेमाल कर सकते हैं. इसका 159 देख रहे हैं एंड इसका 593 का है. एंड व्हेन नाइट्रोजन एंड ऑक्सीजन मिक्स करके ये दोनों 159 प्लस 593 752 आना है. सो दिस इज एप्लीकेशन ऑफ डाल्टन्स लॉ ऑफ partial pressure, right? Are you getting or not? Are you getting or not? So this is again we are going to use in the Henry's law as well as Raoult law. Let us go into the details. So Henry's law का जो formula pressure of the gas is equal to Henry's law constant in the mole fraction. यहाँ पर solubility is directly proportional to pressure of gas. You can say pressure of the gas is directly proportional to solubility. Let us say mole fraction is the function of solubility, so that we can say P gas is mole fraction of the gas in the liquid. So P gas is equal to Henry's law constant in the mole fraction of the gas. That's what I want to explain you here. So mole fraction of gas is equal to number of moles of gas upon number of moles of gas upon number of moles of, मान लो ये solvent water का है. Okay, if the water is 1 kg, it is going to be number of water molecules moles is equal to 55.55 होगा. So no need to calculate, आप directly इस्तेमाल कर सकते हैं. Yes संगीत है ना बेटा? सो हम आपको जो जो ट्रिक्स दे रहा है ना ये सीधा इंपॉर्टेंट है. और नीट एग्जामिनेशन में ये ट्रिक पकड़ के आप आधा न्यूमेरिकल सिंपलीफिकेशन बचा सकते हैं ना. हाँ बचेगा ना, है ना? वेरी गुड, नाइस, ग्रेट. सो हियर P is the pressure of the gas, KH is the Henry's law constant, and X is the mole fraction of the gas in the solution, है ना? Yes. Number of moles of the gas upon number of moles of the gas plus number of moles of the solvent or the liquid. You can see, my dear student, number of moles of the gas can be ignored, can be, if possible. इसका वैल्यू अगर छोटा है, छोटा से छोटा है, इग्नोर कर सकते हैं, है ना? वो भी एक मेथड है न्यूमेरिकल करने का, वक्त में आपको सिखा दूंगा. सो डाउट, क्या डाउट है आपका? डाउट क्या? जल्दी बोलो फटाफट चैट बॉक्स में, जल्दी. अभिनव आपका डाउट क्या? What are it? I am teaching about the solutions on colligative properties. Here we are discussing about Henry's law. Is that fine? Is that fine? So you came late now, that's why you don't understand what we are teaching. So you just go in the flow, you'll understand. ठीक है? एक thumbs up दे, एक thumbs up दे. Right. Now hundreds of students are using this YouTube platform and getting benefit of this. So we request attend the class without any fail on a regular basis so that you can do the best. Logavanagam, I think you are watching recordings of this, right? That's good. Now let's talk about the graphical representation of Henry's law. Henry's law says pressure of the gas is directly proportional to Henry's law constant and mole fraction of the gas. If you take a P gas, is directly proportional to mole fraction of the gas, KH is a constant. So the pressure and the mole fraction, if you take, you are going to get a straight line passes through the horizon, slope is going to give you Henry's law constant. So NEET examination में आपका ग्राफ्स भी काफी इंपॉर्टेंट है ना, ग्राफ्स भी आप एडवांस कर सकते हैं. सो जो भी चीज आप सीखना चाहता हो तो पहले सीखो बेटा. Okay, now let us talk about, if you take the pressure versus mole fraction, so graphical analysis as T1, T2, T3, ये T1 में pressure and T3 में pressure, what is the relation between T1, T2, T3? Chart box में prepare for NEET, very good. Chart box में देना ये तीनों का मोल फ्रैक्शन किसका ज्यादा है, एक प्रेशर में आप लेना है. So that gives you the T1, T2, T3. So अगर टेम्परेचर ज्यादा होगा तो प्रेशर ज्यादा होगा ना. T1 is greater than, T2 is greater than T3. So that is your answer for this particular graph. So this I can understand Hindi. Can you speak in English? Yes, definitely we can discuss in English, not a matter. Yes, definitely. So in the NEET examination, the relation between T1, T2, T3 will be asked. Here at higher temperature, pressure is going to be high. At low temperature, pressure is going to be low. So that we can say T1 is greater than T2 is greater than T3. Okay. So we can say yes, T1 is greater than T2 is greater than T3. So this kind of analysis is required for NEET examinations. At higher temperature, pressure will be high. That's what I just want to say. Higher temperature, pressure is high. Low temperature, pressure is low. Temperature and pressure is directly proportional. Charles Gay-Lussac law. So anything we connected with the gaseous state, thermodynamics, basic concepts of chemistry and everything. So you follow in the same flow. Are you getting or not? Clear? Right. So what is your name? Your name is shown that it is DP sisters. Okay, pressure, and it is A given, B given and C given. Pressure versus mole fraction. The relation between the temperatures of isotherms of this is given as A and B and C. T1, T2, T3 फिर भी T1 is greater than, T2 is greater than T3. We already discussed in the previous graph. Hope you can see here. That's very important. A is greater than, B is greater than C. That's what it is. Henry's law constant 1 at this temperature is greater than Henry's law is constant 2 is greater than Henry's law constant 3. I want to say, as temperature increases, solubility decreases. This is one thing. And as Henry's law constant increases, solubility decreases. So Henry's law constant is a constant. It is constant for a gas at a constant temperature. The Henry's law constant is a constant, changes with gas to gas. For a given gas, as temperature increases, Henry's law constant value decreases. I don't know why it is called as a constant. Yeah, हमेशा बदलता रहता है. It appears like a variable, but it is a constant. Okay, at a given temperature, है ना. ये चीज़ बहुत important है. ये NEET examination में आप directly use, and ये trick है ना, आप theory and analytical oriented question निकालने के लिए पे सीधा इस्तेमाल करो बेटा, है ना? That's good, very good. अभिनव, logam and eigam. Okay, so let's see how the students are reciprocating here. Now, characteristics of Henry's law constant. KH का बारे में बहुत संगीत. Yes, let's see. Same unit as the pressure. It could be मान लो ये atmosphere bar mmHg. What is the unit for the pressure? That is the same unit for Henry's law constant. Pressure increases, solubility increases. Yes, of course. Yes, of course. Logam and logam, you said correct. And characteristics of Henry's law constant, it is different. Gas liquid system has different Henry's law constant. I mean to say, oxygen dissolved in the water at 25 degrees centigrade, its KH value is different from oxygen dissolved in hexane, some other liquid at 25 degrees centigrade. It all depends upon gas liquid systems. That's very, very important. So पूरा एनालाइज करके ये स्टेटमेंट्स आपको दे रहा हूं मैं. KH increases with temperature. So KH increases with temperature. That's what we discussed in the previous graph. And also KH depend on intermolecular force between gas and liquid. So many points. Which of the following is true? NEET examination. I think आप पहचान है इसे तरह questions हाँ. Which of the following statements are true? ABCD options ऐसे दे सकते हैं. And you can get the appropriate answer based on this. Clear? Got it? Yes. So you can download Infinity Learn app and you can click on the Infinity Learn NEET ka link and you can get the best out of it, right? Very good. So we'll go ahead, and the KH value decreases with increase in the solubility. I just already given solubility, KH value increases, solubility decreases. KH value decreases and solubility increases. And these are the 1, 2, 3, 4, 5 amazing facts about Henry's law constant. Amazing facts about Henry's law constant, my dear students. It's very, very important. So which of the following is true, which of the following is not true, and NEET examination, you can get 20% of this questionnaire is based on this theory statement oriented. You can get statement 1, statement 2, assertion and reason type questions in the NEET examination. My dear students, you just focus on the way you prepare and don't feel simply ratta maro aisa mat karo, hai na? Right. Okay, Sangeet, is that clear? Ha, yes. Now let's talk about limitations of Henry's law. अरे हर लॉ को भी लिमिटेशन होता है ना. इसका लिमिटेशन क्या? The pressure shouldn't be too high, pressure shouldn't be too low. And the limitations of Henry's law, and Henry's law is only valid under these following conditions. Again, statement based questions are important here. So let's talk about pressure of the gas is not too high and the temperature is not too low or high, and gas should not have any chemical reaction with the solvent. How do I know? You want to discuss ammonia is a gas and H2O is a liquid, and ऐसे रिएक्शन मिक्सचर को ये हेनरीज लॉ कांस्टेंट इस्तेमाल कर सकते हैं, ना ही इस्तेमाल करना है बेटा. अंडरस्टैंड? क्लियर? And gas should not undergo any reaction with the solvent and dissociation or association with the solvent. So these are the 4 amazing points that you need to know about the Henry's law constant. Clear? Okay. So let's talk about applications of Henry's law. Now get ready for amazing animations that you can see. Hope you like it. Sangeet? Right. So let's talk about soda. Soda is nothing but carbon dioxide dissolved in the water. So when you open the soda, so you are going to see the fizzing out. You know? Why the fizzing out? Pressure is released, solubility is decreased. है ना? So you can see to increase the solubility of carbon dioxide in soft drink and soda water, the bottle is sealed under high pressure. That is the important application. Everybody can see in a regular daily life. Here you can also see and high altitude the partial pressure of oxygen is less than that of ground level. So partial pressure is more in this normal stratosphere, troposphere है ना. So if you go into stratosphere, gas density is less, so that we can see the flights, super jet, supersonics and satellites, you can see here partial pressure is less. Got it? Anoxia condition भी बोलते. If you take mountaineers, their oxygen conditions are very less. That also I just want to show. Low blood oxygen causes anoxia. Logonaigam. Nice following in the lecture. Appreciated. So that's what you see. The person who are in climbing, they cause anoxia because at high altitude they have the low low oxygen concentration. So partial pressure, let's say you can take less oxygen, so that's why they take oxygen carrying masks along with them, right beta? Okay, arre beta. So you want to go along with him? You want to go along with him? You have that guts? Logvanagam, you want to go there? Okay, so how do you feel these animations and all? Now let's see applications of Henry's law. Oxygen diluted with less soluble helium gas used by sea divers to avoid bent. So what happened? The scuba divers who are in the deep sea, they carry oxygen along with helium, so that you don't take the air, they don't take the nitrogen. If they take the nitrogen, they come out and the dissolved nitrogen is going to be a bubble and it is going to pop up, and the internal blood vessels are going to be broken. That what you call it as a bent. Okay, that what you call it as a bent. So the one who is coming on the surface, they experience kind of pressure feeling, that is called bent. That is a reverse process of solubility of the gas from the blood. Okay, so that clinical condition you call it as a bent. Okay, Logovanagam, you just want to go one day when you grown up, right? Okay, now let's talk about oxygen diluted with less soluble like gas is used to sea divers to avoid bends, and painful effects during this decompression of the dissolved air in the blood of scuba diver is called as a bent. Right. Now this is what you call bends. Okay, liquid solutions. So liquid solutions, from there you talk about the vapor pressure. This is very important. From the vapor pressure you talk about the Raoult's law, right? We'll go directly into that without any delay. So liquid solutions. Stay tuned, you're going to get amazing slides so that you will be having the better understanding of the concept. अगर आपका कॉन्सेप्ट अच्छा होगा तो एप्लीकेशन भी अच्छा हो सकता है ना, हो सकता है. संगीत kept quiet संगीत Logavanagam, DP sisters, Anamani. So let's talk about the liquid. Vapor pressure is the major concept. Yes, vapor pressure. Yes, I am teaching in English only, don't worry. Meanwhile, water in ethanol. Yes. Meanwhile, if you get kind of in Hindi and you just eliminate it, and whatever I am teaching, DP sisters, it in English only is not an issue at all. Right? Water in ethanol, vapor pressure. When you talk about this liquid and the liquid molecules are evaporating, and this is what you call it as a vapor, and the process is called as evaporation. And in this evaporation, the liquid molecules again come and heat on the liquid surface, and the pressure caused by its own vapor at equilibrium on its own liquid is called as vapor pressure, and this is what you call it as a liquid vapor equilibrium. And this equilibrium, you can see the liquid molecules making a hit on its liquid, right? And this hit exact kind of pressure, right? That pressure, what you call it as vapor pressure. Got it? Amazing slide. You like this slide? You like this slide? One thumbs up. Logavanagam, one thumbs up, right? Very good. Nice. Now this is what you call it as a vapor pressure. So calculation of vapor pressure, you can calculate it at equilibrium. The rate of evaporation and the rate of condensation is equal, and at that position H2O liquid and H2O gas at equilibrium, and hence the vapor pressure is the equilibrium constant of the reaction. So it is linked to chemical equilibrium. It is also linked to thermodynamics. Yes, physical chemistry means don't feel that it is full of numericals. Physical chemistry means it is physical aspect of the chemical changes. Okay, there you are connected to solutions and colligative properties is connected to here equilibrium, thermodynamics and a mole concept, everything you are connected, right? So that you can say here Kp is equal to partial pressure of H2O, so why it is not linked to gas? In the while writing Kp, liquids are not taken, right? So I just want to say liquid vapor equilibrium H2O liquid, H2O gas, so that you can say vapor pressure, simply you can say the pressure exerted by the vapors of the liquid when equilibrium is established between vapors of the liquid. That's what we shown in the animation, right? Dear students, this is the exact definition of the liquid vapor equilibrium vapor pressure. Clear? That's good. So you can see, now let's go into the details. In the vapor pressure, technically you can say the pressure exerted by the vapors at thermodynamic equilibrium with its condensed phase at a given temperature is in a closed system. That is technically true, right? Okay, now let's see condensed phase. Liquid 10 grams, temperature is 0 degrees centigrade. Liquid less than 10 grams is seen whenever you can see at equilibrium. So what happened, what is the exact mass of the liquid here? It is less than 10. So regard what about the other part of the water molecule? They are in the vapor phase. It is in the closed system, right? Yes. Whatever I am discussing here, it is purely theoretical, and I am taking you as if you are in a laboratory and you are observing by doing some experiment. Yes, that is required, right? So let's see. So condensed phase in solid state. So directly it sublimes at atmospheric pressure and temperature. So like example, you can take the substances which can sublimate camphor, curpur and naphthalene, benzoic acid, talic acid, so many substances, ammonium chloride. These are all the examples that can sublimate. They directly convert solid to vapor directly, and rate of sublimation is equal to rate of deposition. And in the same dry ice, iodine, camphor comes under these examples. So we are not in that particular aspect, just I want to say what is the thermodynamic aspect there, right? So continuously given the flow of the subject in the 90 minutes without any delay, without any lag. So you take the version of the total concept that is given by Suresh in the Infinity Learn studio. It should be there in your notes. Yes, Hitman. रिजल्ट कितने बजे आएगा? तब तक अरे यकीन नहीं है, कुछ भी करने दो, इसका यकीन नहीं है. सो लेट इट बी. ओके, आता है फिर वही रिजल्ट है ना कि हिटमैन. सो मीनवाइल यू एंजॉय द क्लास, राइट? Now let's talk about when you heat a liquid, what happens? It is going to evaporate, and when it is evaporating, you can see its evaporation vapor pressure is increased. Got it? Got it? Yes. You always feel डर लग रहा है, डर लग रहे हैं, डर के बाद भी कुछ नहीं है बेटा, अच्छा सोचो अच्छा होगा, बार बार मैं ऐसे बोलना कोशिश कर रहा हूँ आपको. ओके, सो एनीथिंग यू थिंक something will happen that gives you more fear in you. So you think light, so anything comes you have to admit it, right? So this is a part of life, we go along with the sailing, right? Logarithm. So what I mean to say here, condensed phase solid does not sublime at room temperature and pressure, and vapor pressure is negligible for the substances. And you can say it is important, very important, vapor pressure does not depend on surface area. सेशन के बारे में देख के आपको कमेंट बॉक्स में बता दूंगा, आप कैसे देखूंगा मैं. ओके, ठीक है. आज आएगा ना, शायद नहीं आएगा. कोई बोला है कि आज आएंगे नहीं आएंगे, शायद नहीं आएंगे. ओके, vapor pressure is very important about the vapor pressure. So vapor pressure depend on the temperature, but not vapor pressure depend on temperature, nature of liquid, and nature of anything, but it is not depend on the surface area. When the surface area is increased, rate of evaporation increases, but vapor pressure is not increased. You can see, this is the example that I can show you. Vapor pressure points to be noted. You can see vapor pressure does not depend on first surface area. सिलेबस शायद मेरा केमिस्ट्री जनवरी तक होना है. इन द मंथ ऑफ जनवरी we will be discussing about marathon sessions and one shot sessions भी है. Okay, till then only topics ऐसे चलते रहते हैं, we have to follow it. Is that fine beta? Now, so vapor pressure does not depend on surface area and the shape of the container and the amount of liquid taken. So these are the three main important points. Why? Because in the NEET examination, for which of the following the vapor pressure is independent. So like that, theory oriented questions. So this is such a classified slide that I am giving to you. You can just go ahead with this same kind of revision and you can do the best. Clear? Right. Now let's talk about comparison. Let small surface area, same amount of liquid, temperature is same, and a large surface area, let us मान लो ये वाला 25 डिग्री सेंटीग्रेड का है ये वाटर है ना, एंड ये भी वाटर है, एंड जब तक 25 डिग्री सेंटीग्रेड टेम्परेचर कांस्टेंट है, वेपर प्रेशर आपका कितना दिख रहा है, इट इज़ अबाउट 60 70 80. हियर इज आल्सो द सेम, इट इज आल्सो सेम. वेपर प्रेशर ये दोनों में सेम दिख रहा है ना. यस यस, इट इज the best demonstration I can give you. 24 tar, you can say that. Yes, logarithm, yes, that's good. जब तक टेम्परेचर कांस्टेंट है, ओके, आपका वेपर प्रेशर भी कांस्टेंट होगा. ओके, DP sisters, as long as the temperature is constant, the vapor pressure is also constant. That I want to say there, right? Now one more important thing, vapor pressure does not depend on the surface area. आपका प्रूव मिला? Yes, it is accepted. I just want to say comparison here. Factors affecting the vapor pressure. Factors affecting the vapor pressure. Now first one, vapor pressure depends on surface tension and the temperature. कम surface tension है, कम surface tension vapor pressure ज़्यादा है, temperature ज़्यादा है, vapor pressure ज़्यादा है. That's what. So surface tension increases, vapor pressure decreases, and the temperature increases, vapor pressure increases. बस खास बात है, very simple, right? That's good. So you want to see the explanatory slides. You can surface area, bulk of the liquid, as the surface, the liquid molecules are tangled and they have the more intermolecular forces. Higher intermolecular forces, higher is the surface tension and the lower is the vapor pressure. Simple. There are 3 points, point 1, point 2 and point 3. See how simple a big complicated concept Suresh sir is giving as a simple parameter. That's the reason why surface tension increased. You just say water and you take coconut oil. So water evaporates but coconut oil do not evaporate because coconut oil ka surface tension ज़्यादा है. Understand? Now the intermolecular forces at the surface would directly influence the surface tension, which varies inversely with the vapor pressure. So Logavanagam is my voice is low. Confirm Hitman, can you able to hear me? Annamani, you please confirm, can you able to hear me? Yes, check your internet connection, Logavanagam. DP sisters. Abhinav, can you please confirm is my voice is audible or not? Is my voice is audible or not? Yes, voice is fine. So Logavanagam, Sangeet, thank you. So Logavanagam, you just check your audio settings or internet connection, that's why. Okay, let's go ahead. What I mean to say about the hand sanitizer. अरे कोविड का समय में ज़्यादा इस्तेमाल किया, हैंड सैनिटाइजर इस्तेमाल करके करके हाथ पतला हो गया है ना. So let us use the hand sanitizer. Let us observe a broad spectrum antimicrobial. This one contain ethanol as a solvent. It contain ethanol 70% by volume है ना. Now I just want to say something. I just want to do with the hand sanitizer. Hand sanitizer है ना, उसमें क्या ethanol है. Now let us take a water and a hand sanitizer. Let us see what is going to be observed. Yes. Hitman, thank you very much. And you can see this is your water and take a drop of water and put it on the surface. And it is hand sanitizer. आपको क्या दिख रहा है? अरे सैनिटाइजर इवापोरेट हो चुका, लेकिन वाटर नहीं है क्योंकि ये वाटर इट हैज़ मोर सरफेस टेंशन, इथेनॉल में सरफेस टेंशन कम है. Are you getting or not? You can see it is evaporating. You can say it is evaporating, right? So what I mean to say, this is a kind of live sessions where you will be visualizing the unseen chemistry for you guys, so that everybody please give a fire emoji and thumbs up if you really enjoy these videos and slides. Everybody please, because ज़्यादा मेहनत करके ये स्लाइड्स बना सिर्फ आपके लिए. क्यों ये इवापोरेट करते हैं? क्योंकि हाइड्रोजन बॉन्डिंग बहुत पतला है पर एंड वाटर में हाइड्रोजन बॉन्डिंग ज़्यादा है, इथेनॉल में हाइड्रोजन बॉन्डिंग बहुत कम है. शैम्पू से भी सैनिटाइजर बना सकते हैं ना? नहीं 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 नहीं, शैम्पू अलग चीज़ है, सैनिटाइजर अलग चीज़ है. मैं क्या दिया? सैनिटाइजर, हैंड सैनिटाइजर में सिर्फ इथेनॉल होता है ना, सिर्फ इथेनॉल होता है, राइट? Yes, it is. It is having hand sanitizer. Hand sanitizer contain ethanol 70%. Okay, ethanol 70%. Yes, isopropyl alcohol भी है. Yes, Sangeet, I agree with you. It evaporates fast. But shampoo, it contains soap. It contains soap. Okay. So let's talk about effect of temperature. Low temperature. So rate of evaporation is directly proportional to temperature, क्योंकि kinetic energy, kinetic molecular theory के हिसाब से kinetic energy is directly proportional to temperature. As temperature बढ़ते जाएगा, kinetic energy बढ़ते जाएगा, molecular collisions बढ़ते जाएगा, molecule get a tendency to escape बढ़ते जाएगा, vapor pressure बढ़ते जाएगा, है ना? So low temperature average kinetic energy कम है, so that high temperature kinetic energy ज़्यादा है, vapor pressure ज़्यादा है. यस। सो लॉकडाउन में घर में गाँव में अंकल शाम्बू ने बना सैनिटाइजर, नहीं नहीं नहीं, असली सैनिटाइजर बनाने के लिए आइसोप्रोपाइल अल्कोहल और इथाइल अल्कोहल इस्तेमाल कर रहे हैं। ओके ओके, ऐसा बात नहीं। ओके, लेट अस टॉक अबाउट द मोर स्टफ ओवर हियर, राइट, मोर स्टफ ओवर हियर, ज्यादा आगे जाना है। So I mean to say rate of evaporation is directly proportional to temperature. So that vapor pressure is directly proportional to temperature. So that is thermodynamically explained by using Clapeyron equation. आपको पेश कर रहा हूँ. So today's session is going to be lot of animations, lot of fun and a lot of subject as well and a lot of theory NEET oriented question का stuff भी मिल रहे हैं. Okay, that's good. कोविड-19 वापस कब आएगा? वापस नहीं आएगा बेटा, क्योंकि कोविड-19 कोविड-20 बन गया. ओके, कोविड-20 22 बन गया, 24 भी बन गया. सो वी आर विथ कोविड. योर कोविड वायरस इज अराउंड यू. इट्स ए सार्स कोविड, राइट? सो वायरोलॉजी क्लास लेना है क्या आपको? वायरस कैसे रिप्लिकेट कर सकते हैं, कैसे म्यूटेट कर सकते हैं. ओके ओके, इट्स ए सार्स वायरस, रेस्पिरेटरी डिस्ट्रेस के लिए देते हैं. ओके, सो इट इज देयर विथ अस. ओके, ये नहीं गया, आप आ रहे हैं, वापस कब आएगा? वापस नहीं आना है. ओके, नाउ लेट्स टॉक अबाउट effect of temperature. You see, effect of temperature beta. So let's see, temperature of a given liquid. At high temperature, more molecules from the liquid have enough kinetic energy to escape from the surface of the liquid, so that there will be increase in the saturated vapor pressure, so that vapor pressure भी बढ़ जाएगा, है ना? So liquid vapor delta H is positive. Vaporization liquid to vapor is always endothermic process. हीट इज रिक्वायर्ड टू कन्वर्ट लिक्विड इनटू वेपर्स, क्योंकि ये डेल्टा एच पॉजिटिव है, एंडोथर्मिक प्रोसेस है. ओके, इट इज एन एंडोथर्मिक प्रोसेस. इट इज गोइंग टू बी डेल्टा एच इज पॉजिटिव का है. रिलीज चार्ट क्लियर प्रिंसिपल का हिसाब से अगर हीट देने तो ओके व्हाट हैपन, टेम्परेचर बढ़ जाएगा, रिएक्शन आगे बढ़ता. यस Thank you very much, beta. Very good. Let us go ahead. Now, according to Le-Chatelier's principle, increase in the temperature of a system is dynamic equilibrium favors the endothermic change. Thank you. You all love me. Okay. Thank you very much. So we are connected here with equilibrium thermodynamics as well. I told you. So let's see. Now increase in the temperature, increase the amount of vapor present, increase in the saturated vapor pressure, and effect of temperature of the vapor pressure of a liquid is given by Clapeyron equation, that is ln P2 upon P1 is equal to delta H upon R of 1 by T1 minus 1 by T2. ये चीज़ क्या है? So that here it is ln P2 by P1, where delta H is the enthalpy of vaporization. Definitely you can become a doctor and be want to be like me. Yes, you can be. And what is the meaning of enthalpy of evaporation? The enthalpy change when 1 mole of a liquid is completely converted into vapor at equilibrium. And P1 is the vapor pressure of the liquid at a temperature T1. And P2 is the pressure of the liquid at temperature T2. This equation is thermodynamically important. ये इक्वेशन का हिसाब से yes, आपका एक ग्राफ की बना सकते हैं, है ना? So that I want to say vapor pressure and the temperature. हाँ, yes, Hitman, मैं हूँ एक डॉक्टर. Okay, so let's see a graph between the vapor pressure and the temperature. अगर temperature increases, vapor pressure increases. It goes on exponentially, mind it, है ना? So this graph is important. The nature of the graph is important for NEET examination, right? The nature of graph is important for NEET examination. Okay, now let us talk about the vapor pressure of liquid solution. The solute is always volatile liquid, solvent is always volatile liquid. अगर दे solutions mix करके ये mixture में vapor pressure क्या हो सकता है? The mixture of the vapor pressure can be seen, Sangeet. Here the vapor pressure consists of both components of the solution. है ना? कैसे? The partial vapor pressure of each component depends on mole fraction of the corresponding component. So depend का मतलब क्या है यहाँ पर? Directly proportional के बारे में. Directly proportional इसे it is Raoult's law. Okay, Hitman, let's go on academic discussion better. Okay, right. Now let's talk about here. So that is your Raoult law. So the Raoult law says, you can see this is a liquid has some vapors, and liquid B, it has some vapors and its a pressure, and its pressure. When these two liquids are mixed, you are going to get a liquid A and B, and this liquid A and B has a vapor pressure. That is what it Raoult law says how it is related. आप इतना how much A is there, that much vapor pressure of A will be there. That is what is said. So I mean to say here, XA is a mole fraction of A in the solute phase, XB is the mole fraction of B in the solution phase, and P naught A is the vapor pressure of pure liquid A, and P naught B is the mole fraction of pure liquid B. अब मैं क्या बोलना चाहता हूँ? Here you can see yes, it is. This indicates vapor pressure of pure liquid A. This indicates, मान लो ये closed liquids का है P naught B, and it is going to be P naught PA. This is said to be PA and this is said to be PB. So P solution is equal to PA plus PB. So what is the difference between P naught A and P naught B? Okay, so आपका फेवरेट स्टूडेंट कौन है प्लीज बताओ ना. मेरा फेवरेट स्टूडेंट मेरा क्लास में हर दिन आने वाला है बेटा. आप हर दिन आ रहे हैं ना? हाँ, यस, हर दिन आ रहे हैं लेकिन कम चार्टिंग करते हैं. So favorite student is directly proportional to the student who comes regularly to the class. Pure solvent क्या है? P naught indicates a pure solvent and PA indicates which is in the solution. हाँ, आप आता हूँ. Definitely you are my favorite student. Okay, Abhinav, are you there in the session? Yes. Okay, let's see log of an item. So it is said that P naught A vapor pressure of A in the pure state, P naught B is the vapor pressure of B in pure state, XA is the mole fraction of A in solution phase, XB in mole fraction of B in solution phase. Okay. Now when you talk considering both components A and B to obey Raoult law, partial pressure of A is equal to PA is equal to P naught A mole fraction of A. What Raoult law says? Vapor pressure of a component is directly proportional to its mole fraction. So that PA is equal to P naught A mole fraction of A. So P naught A is a constant. P naught A is a constant. Similarly, PB is equal to, is directly proportional to mole fraction of B. Here P naught B is equal to P naught B mole fraction of B. Right? So that's what it is explained here. This is what is Raoult law for liquid solutions. So you are with a lot of enthusiasm, man. Let us focus on the concept. Come on. Now for a solution containing mixture of two volatile liquids, you can see amazing slides. Okay, so the partial pressure of each component of an ideal mixture of liquid is equal to the vapor pressure of the pure components multiplied with mole fraction of the mixture. Okay, so this is nothing but Pa is equal to P naught A mole fraction of A. It is multiple na? It is multiple na? It is simple na? So you learn the complicated thing in a simplified version, right? That's good. So the partial vapor pressure of each component of an ideal solution mixture of liquids is equal to vapor pressure of the pure component into mole fraction of the component in the solution. If more than one is there, so Pb is equal to P naught B and mole fraction of B. So pressure of the solution should be equal to sum of this and this. So P naught A mole fraction of A and P naught B and mole fraction of B. Simple. Simply you add two things. Samjhe? Acha hai na? Are you getting or not? That's good. Great. Good gathering in the class and doing the best. I appreciate it. Now you just say Pa is directly proportional to mole fraction of A and Pa is equal to P naught A mole fraction of A. So if you take a Pa vapor pressure and mole fraction of A, you are going to get a straight line passes through the origin, and this is tan theta, this is your tan theta. This tan theta can gives you the slope for P naught, tan theta. Are you getting or not? Clear? It's very simple. Amazing slides you're experiencing in today's class on Infinity Learn Studio, right? Very good to see. Liquid B, it is going to be seen on the other side. This is for liquid A. Okay, this is for liquid A and this is for liquid B. Okay, if you talk liquid A and liquid B in these two graphs, you are going to get one graph like this. Okay, so I just want to say this is liquid A and liquid B, and liquid 1 ka and liquid 2 ka, and this is going to be total pressure ka. This liquid A indicates, so Pa is equal to P naught A mole fraction of A, and this is studied in this way, and this graph in this way. You want to study the other side of the graph, it is going to be studied in this way and this way. So this indicates Pb is equal to P naught B mole fraction of B, and this is your P solution. So this is going to be P solution is going to be P naught A P naught A mole fraction of A plus P naught B mole fraction of B. You see the beauty of the colors. See the beauty of the colors, right? So A and B. So total Pa plus Pb. So you can say Pa is equal to P naught A mole fraction of the total. You can say from the mole fraction the vapor phase also. If Ya is the mole fraction of A in the vapor phase, Yb is the mole fraction of B in the vapor phase, you can see the relation between this Ya and Yb, and this formula mole fraction of A is equal to Ya P total upon P naught A, and mole fraction of B is equal to Yb P total mole fraction of B. You can say mole fraction of A plus mole fraction of B should be equal to 1, and 1 by P total is equal to mole fraction of A in the vapor phase upon P naught A plus mole fraction of B in the vapor phase upon P naught B. So these formulas are directly used in the NEET examination. You have a couple of questions based on these formulas in the NCERT textbook also, and those questions, once it is asked in the previous medical entrance examination, previous engineering entrance examination. Yes, so done some MCQs. Yes, tomorrow it is all about MCQs, Logavanagam. It's all about MCQs. Today no MCQs in this concept class. Is that fine? Yes. So interaction liquid-liquid solutions, when the solute A, liquid dissolved in the solvent B, the extent of dissolution depends on various factors. First is intermolecular force. So that we'll discuss here, A interaction and BB interaction and AB interaction. If AA interaction and BB interaction are equal to AB interaction, it is going to give you the ideal solution. If not, it is going to give you non-ideal solution. There we are going to see. Right, Logavanagam? So in this, if it is liquid A molecules will have intermolecular forces, A molecule and A molecule, between intermolecular forces will be there, and B molecule and B molecule, there is an intermolecular forces, right? Here once you dissolve in A and B, if you say A and B molecules, between them also intermolecular forces are there. So how they are interacting decides the nature and the behavior of the solution, right? Let's see here, ideal solution where solvent-solvent interaction is equal to solvent-solvent interaction with the solute and solvent interaction. Okay, so the intermolecular forces is going to be the same. You can see intermolecular forces are going to be the same. Now delta H mix is going to be 0, delta V mix is going to be 0. It is written as delta mix of the enthalpy is going to be 0. Delta mix of the volume is going to be 0. There is no change in the volumes, there is no change in the enthalpies. So such solutions are the quality of the ideal solution, and entropy is greater than 0, Gibbs free energy is also greater than 0, because the formation is non-spontaneous. So you can say example N-hexane and N-heptane, bromoethane and chloroethane. Can you give me one more example that can give you the ideal solution? One example, Logavanagam, one example at least. At the end of the session, we are coming to the end of the session. Give me some examples. Some examples at least. Okay. Benzene and toluene. Benzene and toluene. So nature of the intermolecular forces, you need to check it. Logavanagam, are you there? So Anamani, Hitman, come on. Yes, N-butyl bromide, N-butyl chloride. Yes, keep giving. Yes, keep giving. Okay. So let's talk about ideal solutions. So the solution which obey Raoult law over the entire range of concentration are known as ideal solutions, right? So this is for an ideal solution. The graph should be, we discussed, it is going to be like this. So any solution which obeys this graph is going to be an ideal solution. Got it? Yes, very good. Keep like that. So if anything which do not obey this graph is not an ideal solution, it is supposed to be non-ideal solution. That we are going to say non-ideal solution. The solutions which do not obey Raoult's law at all concentrations is called as non-ideal solution. There we can see. Now we are going to see the non-ideal solution. Tomorrow we are going to discuss about the solutions again. In these solutions we are going to talk about non-ideal solutions and their behavior. From there we are going to get into the colligative properties. From there we are going to do multiple choice questions. fine. Logomanagam, right? Logomanagam, fine. And Anamani and Hitman. And today we are done with today's time because time is very less. And get ready for tomorrow's class. We'll discuss so many things tomorrow. And also, my dear students, please like and share and subscribe these sessions. Right? Thank you very much. God bless you. Signing off, Suresh Avari. We got a good swell of sessions. Really, I enjoyed with you guys. And we'll meet tomorrow with more stuff. Thank you. Bye bye. Thank you.